Good morning. You made it to Friday. Here is your video for today. So let's just go ahead and we'll call this 4-3. What we're going to do is we're going to do transition review and naming. Okay, I'm going to give you guys a couple examples to do with naming ionic compounds. I'm just checking the examples I did yesterday. And I want you to, after I write the examples down, I want you to pause the video, complete the examples, and then play the video when you are finished. All right, so we have example 1. Let's do cobalt 3 phosphide. Let's do manganese 1 fluoride.
Mom?
And then for our last example, let's go ahead and do copper, sorry, copper 3 sulfide. Okay, so go ahead, copy these down, pause the video, and complete them. When you're done, play the video. The first one we have is cobalt 3 phosphide. So cobalt is CO. And how do we indicate the charge? We look at the Roman numeral. So that's Roman numeral 3. Okay. Remember, this side is written as what does it have? And this side is written as what does it need? Okay, so phosphide is really phosphorus. And it needs, it's in group 15, it has 5, it needs 3. So we cancel those out. We get COP. All right, the next one is manganese 1 fluoride. So manganese, make sure you wrote that correctly. I gave this to you because some people write it as Mg. And then here's my charge. So 1. And then fluoride is 1 minus. Okay? These cancel out. M, N, F. And then we have copper 3 sulfide. So copper is Cu. Here's my 3. Sulfide is S2 minus, because it needs to. It's in group 16, so it has 6 valence electrons. And these go ahead and they crisscross because they have not like charges. So you have Cu2S3. All right. For our new lesson today, what we're going to learn how to do is we're going to learn how to name formulas. Thank you, Thompson. All right, so when we're naming formulas, you might get something like, let's see here, LIF. All right, and you have to name it. Well, this is pretty easy. You name the first one. Li is lithium. And when you name the second one, you have to change the ending to fluorine becomes fluoride. So we have to change the ending to the second element only, okay? So let's say you had BAS. All right, so you name the first one, that's barium, and we change the ending to the second. So sulfur becomes sulfide. Sulfur becomes sulfide. All right, we'll step it up a notch. Let's do MgCl2. So some students get confused as to why that 2 is there. So where does that 2 come from? Well, if we think back to the formula, Mg2 plus Cl minus, it got the 2 from magnesium. So it doesn't change how you name it at all. It's just, it got crisscrossed. You still name it the same way. So we have Mg, which is magnesium, and the 2 does not change how you name it. So chlorine becomes chloride. All right. I'll give you guys 3 to practice with. 3 I'll give you, let's do K3N. Let's do ALP. And then let's do Cu2O3. So take a minute, pause the video, write these down, and try to complete them. All right, so you should have completed the videos. Sorry, Tom is playing Legos right beside me, so if you can hear him, that's what he's doing. It's kind of distracting. So for the first one, hopefully you paused it. You write the first one as you normally would. This is potassium. And then we change the ending to this one. So nitrogen becomes nitride. All right. Write the first one, aluminum. And then phosphorus becomes phosphide. And then for this one, don't let the subscripts distract you. Cu is copper, and O is oxide. So copper oxide. Good job. So what you should be able to do is you should be able to identify how people wrote formulas incorrectly. In addition to naming. So if I told you that a formula was supposed to be magnesium bromide, and someone wrote the formula as Mg2Br, you should be able to identify what they did wrong in the problem. So if you're looking at this, you're like, well, it kind of looks right. Think about how the 2 get down there. Where did the 2 really belong? The 2 belongs up here with magnesium. So the right formula should be MgBr2. So you should be able to identify what's wrong as well in a formula. Okay, I'm going to go ahead and post this.